Hey everyone, welcome back to CyberSphere Chronicles. If you're new here, don't forget to hit that subscribe button and turn on the notifications so you never miss an update from our channel. Today, we're diving deep into a topic that's essential for anyone working in telecommunications, networking, or even just curious about how our modern world connects. We're going to explore the various types of cables used in communication systems, specifically focusing on fiber optics and coaxial cables, as well as other important cable types. Let's start with fiber optic cables. These cables are a game changer in the world of data transmission. Instead of using electrical signals, fiber optic cables transmit data as light signals through glass or plastic fibers. This technology allows for incredibly high data transfer rates and long-distance communication without significant signal loss. So why are fiber optics so amazing? Well, for starters, they can carry more data than traditional copper cables. Imagine sending hundreds of thousands of calls simultaneously over the same cable. This is because the bandwidth of fiber optics is far superior, making them the preferred choice for internet backbones, long-distance telephone lines, and even cable television services. Now let's talk about the construction of fiber optic cables. They consist of a core, which is the central part that carries the light, surrounded by a cladding that reflects the light back into the core to minimize loss. This design is crucial because it allows the signal to travel great distances without significant degradation. Fiber optic cables are typically categorized into two main types: single-mode and multi-mode. Single-mode fiber optic cables have a smaller core diameter, allowing only one mode of light to pass through. This is ideal for long-distance applications, as it minimizes dispersion and signal loss over distances of several kilometers. On the other hand, multi-mode fiber optic cables have a larger core diameter, allowing multiple light modes to travel simultaneously. While they are less efficient over long distances, they are perfect for shorter distances like within buildings or data centers. Next, let's shift gears and talk about coaxial cables. Coaxial cables, often simply called coax, are another essential type of cable in the telecommunications industry. These cables consist of a central conductor surrounded by insulation, a metal shield, and an outer insulating layer. This construction makes coaxial cables very effective at transmitting high-frequency signals with minimal interference. You may be familiar with coaxial cables if you've ever connected your TV to a cable box. They're widely used for cable television, internet connections, and even some types of data networking. One of the key advantages of coaxial cables is their ability to maintain signal quality over long distances, making them a reliable choice for residential and commercial installations. When it comes to bandwidth, coaxial cables have a good capacity, but they can't compete with fiber optics in terms of sheer data transfer capability. However, they remain popular due to their cost-effectiveness and the fact that they can carry power along with data, which is particularly useful in certain applications. Now, let's explore some other important cable types that play a role in our communication networks. One of these is twisted pair cables, commonly used in Ethernet networks. These cables consist of pairs of insulated copper wires twisted together to reduce electromagnetic interference. There are two main types of twisted pair cables: shielded twisted pair, STP, and unshielded twisted pair, UTP. STP cables have an additional shielding layer to protect against interference, making them suitable for environments with high electromagnetic noise. UTP cables, on the other hand, are more commonly used in everyday networking scenarios due to their lower cost and sufficient performance for most applications. Then we have power cables, which are crucial for providing the electrical energy required by our devices and systems. These cables can come in various forms, including low voltage and high voltage cables, depending on their application. Understanding the differences between these cables is important, especially for anyone involved in installation or maintenance work. Now that we've covered the main types of cables, you might be wondering how to choose the right cable for your specific needs. The decision often depends on several factors, including the distance of transmission, the environment where the cable will be used, the amount of data that needs to be transmitted, and budget considerations. For long-distance, high-speed applications, fiber optics are generally the best choice. If you need something more cost-effective for shorter distances, coaxial or twisted pair cables might be more suitable. It's also worth mentioning that the future of cable technology is constantly evolving. Innovations like hybrid cables, which combine fiber optics and coaxial technologies, are starting to emerge, offering the best of both worlds. These hybrid solutions can provide higher speeds while maintaining the advantages of existing infrastructure. In conclusion, understanding the different types of cables, from fiber optics to coaxial, is essential for navigating the complex world of connectivity. Each cable type has its own unique advantages and applications, and knowing when to use them can greatly enhance your networking capabilities. If you found this information helpful or learned something new today, please give us a thumbs up and share this video with your friends and colleagues. Don't forget to subscribe to CyberSphere Chronicles for more insights and information on cable technology and connectivity. Thanks for watching, and we'll see you next time.